So from elastic muscular arteries into the arterioles, we now enter into the capillaries or the capillary bed. Okay. One individual capillary or a whole bunch of them congregated together. All right. Capillary bed. These are our smallest of the blood vessels. Again, they're only what, as you can see there, they're only they're only 1 millimeter, or sorry, 8 to 10 micrometers in size, 1 millimeter long. So these aren't really big at all. I'm not going to ask you the numbers. I'm not going to ask you the size of these things. They are the same size as a blood vessel, as a red blood cell, which is, well, really all of the formed elements can make it through a capillary, but capillaries themselves are the same size as a red blood cell. And that's awesome. Red blood cells come in through a single line, which again is even more fantastic and awesome. It ensures that I get enough surface area interacting with the wall of the capillary with the red blood cell. So I really ensure an optimal exchange of nutrients, waste, fluids, all that stuff. Okay. When we look at capillaries, 3 different types. Everything comes in 3s, right? 3 is a magical number. Continuous, fenestrated, and sinusoid. And all of these are based upon one aspect. All of these capillaries are based upon one aspect. Is the endothelial layer intact? That's it. If it's intact, it's continuous. If it has tiny little holes, fenestrated. If it has big old gaps and windows in it, sinusoids. That's it. That is it. So if you know that, I could put up a dang picture on the exam and you could tell me exactly what type of capillary it is. It's that easy. Here is continuous. You can see that endothelium is intact. One little simple squamous epithelial cell comes in contact with another little endothelial cell. That's it. You can see there's small little gaps that exist there between these, and they call them intercellular clefts, but boring. They're the most common capillary we have. When you think of a capillary, this is generally what you think of. They're found all over. I don't really care. They're most damn common. Really, anything can go through these except big things. Proteins. They generally can't pass. So if you have a region where you know it's a continuous capillary, which is the vast majority of them, if proteins are getting into different regions where they're not supposed to, then you know you have inflammation going on. Fenestrated. Fenestrated just means little holes, little windows. Okay. What is going on? Okay. So with this one, the endothelial is still continuous, but as you can see, it's perforated with a bunch of tiny little holes or pores. These pores they're open, right? So if they're tiny little holes or tiny little windows, however you want to visualize it, they're going to let more stuff in. Okay. Just like if you had holes in the wall of your house, more wind is going to come in. Okay. Makes sense. Awesome. Where do we see these? We're going to see these in areas where we have a ton of fluid exchange or fluid transport occurring. So in the intestines, we find these a ton. That's where primary nutrient absorption is occurring within the small intestine. So it would make sense that we would have a very large number of fenestrated capillaries there. Another major region where we would find fenestrated capillaries is in the kidneys. Kidneys filter the blood and form urine. And I know we haven't talked about either of those two yet, but damn it, it makes sense that, this is where we form urine. I imagine you already knew that. So it would make sense that we would have a lot of fenestrated capillaries. Some smaller plasma proteins can get in because of those tiny little holes, but not every single protein, which is good, right? Because proteins exert a force. We talked about that way back in chapter, God, I don't even know, 18? Is that what we talked about blood? I can't read. It's too far away. Okay. But fenestrated capillaries have tiny little holes to exchange more stuff. The last one here is sinusoidal or sinusoids. Sinusoidal type of capillaries have large windows within them. You can see that the endothelial lining is not complete. The opposite of complete would be incomplete. So a hell of a lot of stuff can be filtered out of these type of blood vessels. Where would we find these? These are going to be a lot more associated with lymphatic system, with the endocrine system, okay? Where we have endocrine organs, we are going to have a large number of these capillaries perfusing through them. Endocrine type of organs or endocrine glands secrete hormones into the blood directly, not through ducts or tubes or anything. So it would make sense that they would need a lot of exposure to the blood to get a lot of these big molecules out into the blood. Same thing when it comes to bone marrow and spleen. Bone marrow, we already know what it does. We know that it makes the formed elements. Red blood cells, those are pretty big. Okay. White blood cells, pretty big. All right. Megakaryocyte, pretty big. So it makes sense that they're going to have large windows to get those big substances out into the blood. Spleen filters old defective red blood cells. Spleen filters out. It's involved with the immune response as well. So it's going to need a large access point to getting stuff into the blood and getting stuff out of the blood. So the spleen is going to have a lot of sinusoidals as well. Liver will have some with it as well. Could have put that one in there because of what it does, but these are the two that I put up there, or three that I put up there. We could have singular capillary going in there, but really it's a bunch of them. Okay? Usually we have a bunch of them, and that's what you see right there. Okay? Capillary bed. There's usually, more than one capillary that goes in and supplies the goods to a specific little segment of the structure. Okay. They're kind of this functional unit, if you will, these capillary beds. They're fed by the arterial system, and specifically it's a meta-arterial. It's just a really small arterial. That's all it is. Okay. The great thing about a meta-arterial, guys, is what it has. Go over here. You see these lip-like looking things here? These are sphincters. And as you can see, this meta-arterial kind of feeds into the capillary bed and forms this channel. And here you can see the capillaries extending off of that thing. Okay. All those are the capillaries. But it's that sphincter. Oh, sphincters. I love saying that word. Sphincters govern blood going into those things. So if there is too much pressure built up within that structure, like when I bend down and tie my shoes, all that pressure that increases when I bend over, right, in the waist. And just bend over right now. Bend over and go down towards your shoes, okay? If you bend down and go towards your shoes like you're trying to tie them, the pressure increases within your abdomen. That's going to compress those capillaries. They're really, really small. So that pressure closes them off. What's the body to do? Well, I'm going to constrict my sphincters because I love saying sphincters, and I'm just going to bypass that capillary bed. Okay. And you can see what it's called, a thoroughfare channel, if you must know. Okay. And these meta-arterioles, it ensures that blood continues to go forward through the system. Do you stay bent over the whole dang time for several hours on end? No, you don't. Okay. Meta-arterioles open back up, the sphincters relax, open back up, and we perfuse that region with blood again, usually a lot of it. And then it catches up, and then it returns back to normal. Okay. There you go. And these things pulse. Okay. And these things pulse. And I keep saying the word perfusion. What the hell does that mean? It's just allowing blood to enter into the capillaries, okay? Which allows gas exchange, nutrient exchange, all that fun stuff. Drop off the good, pick up the bad, okay? At any time, only about a quarter of the blood capillaries or a fourth of your blood vessel capillaries are open. So, I mean, this happens quite a bit. I mean, I'm sitting here now in the chair. I got my legs kind of bent a little bit here. So, I mean, I'm sitting down, I'm increasing pressure. So, I mean, you know, this happens quite a bit. And you're still here alive. And as you move around and as you breathe, changes pressure gradients inside the body, and we survive. Okay. You're still alive. Blood is still moving, even though you may have a little bit of pressure increased in that capillary bed. It's okay. It's okay. Dropped off the good, picked up the bad, and now I'm going to go back towards the heart. Where am I going to go for that? I'm going to go into the veins.